my YouTube channel. Today we're going to learn about something that is used in every electronic device in the world. Do you know what that is? It's semiconductor devices. So what are semiconductors? To answer that question, first we need to learn about conductors and insulators. What is a conductor? A conductor is an element that has low resistance to electric current or lets the flow of electric current. What is an insulator? An insulator is an element that has high resistance to electric current or stops the flow of electric current. So, why does a conductor conduct? Why does the insulator insulate? It's all because of their atomic structure. So for the conductor, I've put iron, and for insulator, I've put chlorine. So for any conductive element, the valence shell or the outermost shell is so close to the conduction band. A conduction band is kind of like a shell, but it's a band. When an electron goes to the conduction band, it can break free from the atom and start conducting electricity. So in the conductor, the valence shell, the conduction band are so close together so the electrons can easily move from the valence shell to the conduction band. In the insulator, however, the valence shell and conduction band are pretty far away. So it's hard for the electrons to go to the conduction band, so they won't conduct electricity. Coming back to our question, what is a semiconductor? A semiconductor is an element that conducts and insulates current. So because it's an element, we can find it on the periodic table. So as you hear, this diagonal line of yellow boxes that starts from boron is the semiconductors. So in different periodic tables, they might have highlighted it different, but in this periodic table, they've used yellow. So boron, silicon, and some other things. So for today's example, we're going to use silicon. But semiconductors do not conduct electricity in their pure form. They conduct electricity when you do the process called doping. Doping is when you inject impurities to the semiconductor. For today's examples, silicon. In silicon, its pure form, one silicon atom bonds with 4 other adjacent silicon atoms using a covalent bond. So what is a covalent bond? A covalent bond is when 2 atoms share the equal amount of electron to each other. So what happens when you dope silicon and phosphorus? You form the N-type. So what happens when you inject phosphorus in? So phosphorus will take a place of a silicon atom and will give off an excess electron because silicon just needs 4 more, but in phosphorus there's 5. So there will be an excess electron. So what happens when you dope silicon and aluminium? Then you form the p-type. In aluminium, there's only 3 electrons in its valence shell. So when it takes a place of a silicon atom, it'll form a hole because there's a deficit of 1 electron. So what happens when you combine the p-type and the n-type? You form a diode. A diode looks like this. So this silver strap here is the negative side or the cathode. So here the black part is the positive or the anode. In electrical diagrams, the diode might have a symbol like this. So for different diodes, this line is curved a little bit. So this arrow here represents the flow of conventional current. Conventional current is the flow of holes, and electron current is the flow of electrons. So then inside a diode, it will look like this. We call this the PN-Junction diode. So here there's the N-type, here there's the P-type. N-type has excess electron, P-type has excess holes. So the excess electrons from the N-type will go to the P-type, and the excess holes from the P-type will go to the N-type. So it'll form a potential difference or a barrier region. So the barrier voltage is 0.7 volts. You can call this the barrier region or the depletion layer. So now a diode can act as a conductor and an insulator because it lets current only in one way. So when it acts as a conductor, it's called the forward bias. So if you want to do the forward bias, first you take the p-type or the anode and connect it to the positive, and the n-type or the cathode connected to the negative. So same poles repel, so all these holes will be pushed into this side, and then it will create the depletion layer, and after 0.7 volts, it will start acting as a conductor and conduct electricity. But when it also can act as an insulator. So when it acts as an insulator, the p-type or the anode is connected to the negative, and the n-type or the cathode is connected to the positive. Same poles repel. So all the electrons from here will be attracted to the positive side of the battery. And the p-type, the holes in the p-type will be attracted to the negative side of the battery. So this will create the depletion layer to get bigger. So now we can represent the current and voltage characteristics in a diode using the IV chart. So the green region is the forward bias, and the pink region is the reverse bias. So what happens is when this starts to rise, that means it crossed the barrier voltage, which is 0.7 volts. But when it's reverse bias, you can just reverse bias it for some time. But if you give like a lot of voltage, for example, 1000 volts or something, then it'll go to the breakdown stage. A breakdown stage is when a diode is dead. Now let's see the uses of a diode. Remember, when I first talked about the diode, I said diode lets current in one way. So that can help us convert AC current into DC current. So normal AC looks like this. It's just a sine wave. So here is a whole cycle. Half of the cycle, this side is the positive and this side is the negative. For the other half, they just change. If you want more information on AC or other related information, please check my AC/DC video. Let's see how the circuit works. This circuit is called a full wave bridge rectifier. So as you see, for the first cycle, this side is positive and this side is negative. When this side is positive, this diode is forward biased and this diode is reverse biased. So when the polarity changes for the other cycle, this side is negative. So then this diode is forward biased, and this diode is reverse biased. The current flows here. So this side is positive, which means this diode will get forward biased, this diode will get reverse biased. So then the rectified output will look like this. To decrease the fluctuations, we use a smoothing capacitor. Then when we use the capacitor, it will finally have a rough DC supply. And also note, there are different kinds of diodes. For example, the Zener diode. Different diodes are used for different applications. That's it for today. Nandri, Vanakkam, subscribe and comment.